Hiya, my name is Phil Radford and I'm also known as Maya Guy. I run a YouTube channel called Maya Guy Tutorials where I'm also sponsored by Autodesk. I create content based around Maya and Bifrost. I started off life working in computer games, then moved into broadcast where I worked on rebranding projects and title sequences, moved into post-production after that. And I'm here today to try and show you Bifrost. I use Maya and Bifrost on the daily. It looks kind of daunting when you first open it, but then again so did Maya when you opened Maya first and saw all of those menus and menus within menus and menus within menus. It's not as bad as what you think, and it's all there for us to level up our game and to offer better content. So I strongly believe there's never been a better time to learn Bifrost, and honestly, if I can do it, you can certainly do it. Welcome to how I made this in Maya with Bifrost. In this video, I'll be taking you through my process of how I created a stunning dusty explosion. With the incredible advancements in visual effects and the constant push for realism, artists require tools that are not only powerful but intuitive to achieve the desired results. Maya, as we know, is an industry-leading 3D animation and visual effects software and has been at the forefront of this innovation. And with the integration of Bifrost, is fast becoming the effects tool of choice within the VFX industry. So what is Bifrost? Bifrost is a visual programming environment for procedural effects and simulations. It gives artists the ability to create highly realistic simulations and render them seamlessly without ever leaving the Maya environment. So by harnessing the power of Bifrost, you can achieve visual effects that are not only visually striking, but also efficient and precise in their execution. So the combination of Maya and Bifrost offers an unparalleled control and versatility, making it really the go-to choice for artists who want to elevate their work to new heights. And whether you're an artist or a TD, you can mould Bifrost to work for you, creating incredible effects, but also to create your own tool set that can be used in another project or by other people in your team. So we're just going to start by importing some objects to flesh out our kind of scene. I got these objects from Quixel Megascans, and I'm just going to place them around the scene. It's important to kind of flesh out a scene early on so that we don't end up with any kind of scale issues. Every unit within Maya equals a meter with Bifrost Aero, so we need to be careful not to kind of simulate anywhere that's unnecessary. It's important to note though that when working with Bifrost, we'll be caching our simulation near to the end of the setup. With Bifrost Cache, we can scale up our cache after the fact. So if we're working with another department, or you're working with someone else, or perhaps you don't want to scale down your geometry, or you've got a character or something that's involved, we can actually scale up that cache afterwards and even move it around the scene. So I'm just kind of setting the scene, trying to make things look nice, get a bit of parallax with the camera and work out the shot really. So going to save the scene, wrap everything up into a group, and then we're just going to bring a camera in, change its settings to maybe 35mm, and we're just going to do a simple pan for now. We could add something more dynamic to the movement as the explosion happens, some kind of camera shake and whatnot. But for now, let's just get a camera working, and then we can kind of get to the next section. So here, I've got this asset that I created some time ago. It's a spaceship. You're welcome to have this as part of the scene after this. But I just animated it along a curve, created some kind of like laser fire, and it just gives us somewhere to actually create the explosion. And, you know, it's kind of cool as well. So just before we get started, just something to note is that I'm working at 24 frames per second. And if we go into preferences and into settings, we can see that I'm working in centimeters. I like to work in centimeters. If I change to meters and other options, we tend to have to kind of start chasing how certain effects work with influences and fields. Things start to look differently. So as an effects person, I like to work in centimeters. So to start with, we're going to be doing particle emission, and I'll just start by creating some spheres for kind of the impact point of the lasers. Now, these spheres, we just kind of need to place them just round about where the impact point is. We can move it afterwards. It's kind of no big deal. That'll kind of do for the left one. And then I'm just going to create another sphere. Rather than duplicating, if I create another sphere, I'll be able to use the history on it if I need to kind of adapt the polygon count at a later point. just get this into place. And about there should do. Perfect. And I'm just going to delete some of the faces because we don't want our particles to be emitting downwards in the scene. And this is going to kind of help us create almost like a charge-like piece of geometry. Almost as if there was like a charge underneath the ground. And that's kind of how we're going to be attacking this. So we've got a piece of geometry. Probably best to name them. Nothing fancy. Emitter 1, emitter 2. And it's probably good practice to just group them just so we can have a clear outliner. So let's get a Bifrost graph open. We can find that in Windows, Bifrost graph editor, and we're just going to middle mouse drag and drop in our two emitters as geometry. You can see there's an input and an output there, and then all of the action happens in between those parts. So we're going to be using basic particles, so we'll just hit the tab key and start typing basic, and then basic particles will come up. And if we right click on that node, then we can explode the basic particles and see what's inside. So we've got a source, collider, and the various elements for the solver itself. So we can plug the geometry into sources and take the particles out the back end into an output. And right now it's just a case of getting that frame range to be correct within the source particles. So we're going to be emitting between 10 and 12 frames, so we've got 2 frames of emission. And to use an end frame, of course, we must tick use end frame on the source node itself. And I'm just going to up the speed in the Y direction so that we just get some kind of like burst outwards. Don't need too many particles for this, so I'm just going to change the rate from 100 to 15. So this is going to be driving the smoke simulation with Aero, and it's kind of a widely used technique in VFX to use particles to drive the velocities of smoke. It just means we can come back to this area and change things easily. So I'm creating a vary source property node. This enables us to add some kind of randomization to our particles. You see that there are various elements that we can use. So this one, I'm going to create a speed vary source, and I'm going to put in the maximum of 5 and then 0.02. We can just kind of start daisy chaining these up. So I can kind of go Control C, Control V to copy. We can add a new property. So this one can control the normal speed, and we'll be able to kind of like direct our particles a little bit more using some of these like randomization techniques. And then, you know, for every scene it's going to be slightly different. You just kind of need to eyeball it and see what works. So just going to duplicate again, and this time I'm going to stick in a size. That's the size of the particle. So max of 0.1 and then 0.0. So I'm just taking each output into each input of the vary source property nodes, and then finally connecting the last one into the source particles. 8 and I think 9, and I think it's important to kind of note that if the particles are too small, then our resolution of our smoke later on is going to have to kind of like be really high. So I'll just select the source particles node and change the rate from 15 to 20, and then we'll select this vary source property node, which has a property of speed, and we'll just change the min amount on that to 0.06. See if that makes some kind of interesting difference. And really a lot of this is going to be personal choice, and the joy of using Bifrost and its kind of procedural nature is that we can keep going back to this section and, you know, changing these attributes, adding new pieces of geometry if we need to, swapping out pieces of geometry if we need to, duplicating graphs. You know, it's a really versatile tool. And so, you know, rather than spending time creating velocities and things that might take a while to simulate with the smoke section of this, we can just use the particles, which are very quick to simulate, to kind of give us an idea of how we're going to drive that smoke. So let's just kind of neaten some things up. We can collapse a lot of these menus and move them out of the way, just so that the graph is like more readable really. So if we right click on additional properties on the source particle, we can create a source color property. Now this is going to enable me to color pick within the scene itself, so that I can add some colors to the particles. And it's not just the particle system as a whole, it's each individual source. So I'm just going to hit tab and type in assign, because I want to get in an assign a material. And with anything in Bifrost, if you want to add a material, you need an assign a material node. So the next thing we need is a set geo property reference. This is just going to enable us to pull out the various colors that we're going to put on different sources. So we'll get that into the scene, and we need to add some text here. So into material property, we need to type in base color, and then in geo property, we just need to type in color. This is only really necessary for like points and meshes. We'll just get a standard surface material in, which is an Arnold material within Bifrost graph editor now. And we'll just plug that into the surface material, this into the geometry, and then the geometry out to the output. And that's our little rendering section done. So let's save the scene, really important. And now I'm going to start creating some more geometry for the kind of inner part of the particle emission. So I'm just going to select this original emission geometry, duplicate it, and I'll do the same for the second emitter. And then we'll rename these in the outliner just so that it makes more sense when we look at it. So this is kind of like the dust that is underground some more. So we're going to have like a more dense particle spread for this section. And we want to kind of use a separate particle system for this, because we're going to want to use like a different source on the Aero smoke sim and control it differently. So we want like an inner part of this explosion and an external part of this explosion, and we want to be able to treat the two differently. Now with anything, reference is king, so I strongly advise to look at real life explosions, how fast they are, and the kind of detail that are actually in explosions. So let's just keep dragging these emitters in, and I'm just going to have a bit of a tidy up. But let's get that second emission going before we go too far with the new emitters. So we'll just drag up the second emission node, and we'll copy and paste this. Anywhere you put your mouse is where you'll paste those nodes to, which is really handy. And we'll just drop down this vary source, because that's where the input starts for the geometry. Drag up the solver section and just put in our secondary source. So we'll just select our source color property 1 connected to our first particle source. Now I can color pick for that source as well, just to kind of like separate them out. Just, you know, just artistically, just pick something that you think works. Maybe a lighter color than that. Yeah. And then these two sources should be working together. We've got both of them seem to be running on the same frame. There's a slight offset, so I might just add that slight offset to this secondary emitter just by a frame. So we'll just select that source particles 1 node. So we go 11 and 13, and that should about do it. Let's just have a look from the main camera how it looks. All good. So in this next section, we're going to be creating like a secondary particle system. But for now, let's just really get things tidy. I'll just quickly show you how to do that, and then I think I might, when it comes to it, speed the video up so that I don't waste too much of your time. So if we just marquee select over nodes, we can create a backdrop, and we can just sort of type in something that helps us understand or help someone else understand what this is. I'll just call this, you know, just named it as a source with an incremental number, and I'll do the same with this one. This allows us to kind of like read the graph better, so when you come back into it, there's not like nodes everywhere, and you just got this really, really nice system. So we can create another particle system now, and so I'll just select all of these nodes, just the first set of sources and the solver stuff, and we'll just Control C, Control V up here, and this is going to be for our inner particles, that kind of like more underground kind of dust. So let's just drop down this vary source property and plug in our first emitter, and we're going to add some more particles to this because we want it to be a bit more dense. So I'll just select the source particles node and change the rate from 20 to 50 for our purposes. So if I just pull this out, put up here, and plug in another version. And then I just think I'll go and select like a darker colour so that we can kind of see this sort of inner part of particles a lot better. We just dock this here and have a little rewind and a play of what we got. And we can see those in the scene at the moment. I think I'd like some more particles just so that we can see them. So any node that's highlighted in the scene, like this source property node, is the node that I'm working on. And I'm kind of just moving quickly through various source property nodes from speed to normal speed. And I'm just going to be playing with the min and the max values. What works for me may work differently for you in your own scene. So it's a good idea for you to just play around with these values in your own scene to get the look that you desire. So yeah, just changing some of these properties on the various sources, just so we get like a bit of a mix of movement going on between the external particles and the internal particles. And it's kind of necessary to do this with a separate particle system, because later on down the line we're going to be creating different types of explosion, and we kind of need to separate out the particle sources, which you can't actually do within one particle system at the moment. You can totally create an inner and an outer particle system, no problem, but we need to be able to separate it out on the other end when we bring it into the Aero simulation, but I'll get to that in a bit. So let's just copy and paste these. Actually, let's just put a backdrop over these first and then name them, just to keep things kind of going neatly as we were before. And we'll just give it a bit of a colour just to sort of differentiate between this particle system and the particle system below it. And we'll just copy and paste this up here, which neatly pastes our backdrop as well. And we can remember from the previous particle system that we need to just adjust that frame ever so slightly of the particles. So we just plug them into the very source and plug the sources out here, and now we should have two sources. So I'm just going to go through and tidy up the graph here. I'm going to create some backdrops for each part of each system, and then I'll create some overall backdrops to kind of encapsulate each system, so it's kind of like obvious if someone else or yourself is going to open this. And I've just changed some colors just to highlight some areas that are kind of important to me and just make them a little bit more unique to other areas of the graph. It just helps for reading the graph better. So everything looking neat and tidy, just how I like it. Let's just dock this down here and just rewind and play and see what we have. So this all working nicely. I think I'd like to see more particles for the inner parts. Just for now, maybe just visually even at this moment, but we can always come back to this and we'll be able to sort of, you know, change any of these attributes, which will have a knock-on effect to our fluid system shortly. So I think I'll just wrap this little section up by, let's just, you know, create a display layer for our emission object, because I don't want to see those anymore. I'll just close that down, just name that emitters. And I do believe we are now ready for our explosion section using Bifrost Aero. So I've gone ahead and added a couple of colliders to the scene, just over some of the geometry where the smoke's going to go and the particles go. These are just extruded back, nothing fancy, kind of low res. I've also added these two objects to kind of like scale out in all directions. They're just animated over about 3 frames. They're not going to have particles emitted from them, but they will have aero emitted from them. And I've also created a really simple low-res collider that I've parented to the ship, which we're going to use as a collider with the aero simulation as well. So if we just get the graph open, we hit tab and we're going to start typing basic aero graph. So if we just right click and explode this, much like we did with the particle solver, you can see we've got a collider. I'm just going to bring in some collision objects that I used for the floor and for the wall at the side. My outliner is slightly off screen here, but I'm just selecting both pieces of geometry for the colliders, middle mouse dragging those into the graph. And they come in with the text on the node which says input by path. That just means that there are more than one piece of geometry within this node. just so if any smoke kind of like hits those areas, it kind of collides off of it nicely. So we'll set this to absolute, get rid of that bounciness and the friction, and then we'll just duplicate this, connect this up, and then we're going to bring in the collider shape for the ship itself. Plonk this in here. So I'm just changing that inherent velocity to 0.3. A value of 1 is quite high, which means that when our ship's collider goes through that smoke, a lot of the smoke is going to be dragged along with it. Value of 0.3 is kind of like a nice lower value, and we can kind of take it up or down from there so that that smoke doesn't follow the ship as much in the first place. We can lower the inherent velocity for the collider, because too much is just going to blow the smoke everywhere. It's quite a handy little attribute actually. So now with the source air, we're just going to drag that in, drag the particle output from the material into the source air. And what we need to do is create a source color material like we did on the particles. But this time we're going to pick up the color from the actual particle itself, and it's going to come all the way down the line. And the way that we do that is we use a thing called a get geo property node. This allows us to get like various attributes from other areas. So we'll just plug that in there as well. And what we need to do is grab this property that is called color. So in the property for the geo property node, we'll put in color, and it's an array math float 3. We have to set that. We're just going to plug the data into the base color. We can see in there that it says voxel color. It's just something to note for in a minute. We're going to have to add that to the shader, the volume shader that we're going to use. So we'll just call this trails. And now we can start doing some of the shading aspects, just so we can start seeing things in the viewport. So the first thing we need is an Aero color post-process node. I'll just start typing that in the tab. And then we're going to need an assign material. So we just start typing assign material. You can actually drag ports out and type at the same time, just like this. Just start typing, you hit tab, and it just kind of connects it straight away. So we're going to stick in an Arnold standard volume material here, and this is where we're going to need that voxel color to paste that into the scatter section of the Arnold volume shader. And we just put down a little fresh output node. There we go, just neaten things up a bit, little backdrop, just call this shading, and it's just keeping everything neat and tidy. So let's duplicate all of this. Actually, let's deal with the attributes first. We'll change it to absolute, get that fluid detail size down a bit, change the fog density to max again for the temperature, and then speed I'm going to have this set to set, and inherent velocity we'll keep this low for now because we don't want too much air pushing out around it. Something like 0.2 is going to work well. These are just some settings that I've tried and tested, so feel free to use your own. So we'll copy and paste this, and now we want to do that inner section of particles. So we just did the trails. So again, we're just going to plug in the output of the inner section into that get geo property node and bring the source air out into the solver. And we don't need to change anything. That's all set up straight away just because we copied and pasted it, which is handy. We'll just call this something fancy like inner. Yeah, that's sorted. So a little bit of tidying up. And we'll just have a little play. Let's just dock this. Have a little play, see what we've got going on. So I'm just using an area light, if you wondered at the moment, just so that we can see some sort of real-time shadowing coming off of the smoke. Just an Arnold area light. And if we unpause this, rewind and play, we should get something that resembles smoke and dust. There we go. As you can see, it's picking up the colour from the particles that we assigned earlier, which is really cool. It's not very puffy at the moment, so everything's kind of looking quite streaky, and we can just address that. Let's just see what we can do to make this look a little bit more interesting. So the first thing we can do is we go into the Aero solver itself and change the style to fluffy. There's a few different ones in there you could try. I'm going to leave buoyancy and stuff like that for now. And let's just have a quick look at the inherent velocity and the air properties of the trails, because I actually think I'd like that air to be pushing away from the particle rather than pushing in front of it. So if we put in a minus number here, so minus 0.5 there, that smoke should start kind of going backwards a little bit. So on this source node here, I'm just going to change the end frame to frame 18, and I'm going to scroll down, and that fog density, I want to bring that up a bit so the smoke's a bit more thick, and so I'm going to change that value to 5. And for the inner smoke, I kind of want it to stop following the particles at a certain frame, so that then it will stop following the particles and then start to drive itself under its own buoyancy. So you'll see what that looks like. So I think it's time to add some influences. So we'll just hit that tab and start typing pyro. Then we can introduce an Aero pyroclastic influence. What an amazing name that is. So this node has 2 ports, vorticity influence and drag influence, and I'm just going to drag both of those into the solver influences port. We can actually just use either one of these, but in most cases we'll want to put both in so we get the full functionality of this influence. That's going to give us the kind of noise that we'd get, you know, from like a volcano, those kind of like big smoky explosions. And that's just going to help add some vorticity and sort of, you know, drag into this. And we're also going to lay down a dissipation influence, and that's going to help us dissipate the fog density over time based on a rate. At the moment we've got that set to 1. Let's just put a little backdrop on it just to sort of keep this tidy and readable. Influences. There we go. And rate, we'll probably start this lower, maybe 0.5. And I think I'm just going to leave these settings alone for now. Pyroclastic. And then we should just have a quick little play just to see if we're going in the right direction. Now, something I found when doing like smoky, dusty explosions is that we kind of need a bit of force to it. So usually you would use combustion for an explosion that had a kind of fire in it, but we can use it in this case for this kind of thing as well. So on the solver, I'm just right clicking on additional settings and add in this Aero combustion node. I'm going to change the expansion scale from 1 to 0.3. The expansion scale is going to kind of deal with the size of our explosion, so we want to keep it kind of small. And I'm also going to change radiative heating to 0. Radiative heating, it will generate more heat and kind of explosive nature, and we really don't want that in this particular simulation. But for if we're using combustion, we need the fuel on each source. So you just right click on the additional properties and create a source fuel. And what we have to do here is kind of create an ignition temperature. Set that to butane. That's going to work with the heat source, which is actually the source air itself. So we'll just put again a source fuel on the other object. Set that to butane, the ignition temperature at kind of 200 there, and as long as our source air temperature is higher than our actual fuel, then ignition will occur. So actually I'm just going to change the ignition temperature on those fuel sources. I'm just going to bring that down to about 100 actually, because it's a little bit too close to the air temperature. We'll just test again. We should get some combustion happening. Here we go, kaboom. Now, the explosive look isn't what I'm going for on this. I'm trying to do something dusty. So it's quite easy to sort this out. If you wanted to go for an explosive look, feel free to kind of, you know, move forward in this direction, you know, using the fire and explosions. It's you know, it's a lot of fun. It's a good look, but it's just not the look that I'm going for. So just going to pause this and show you how we can actually use combustion and not actually, you know, see the fire and whatnot. And it's kind of straightforward, really. So we just go into the volume material and just go down to temperature and zero that out, and then we can see that we've literally just got smoke going on. So I'm just going to do a quick play blast and see what we've actually got going on. Let's just run through this a few times. It's kind of cool. It's kind of like lifting up too high for me. Ba-dum. Yeah, it feels a little bit too light and airy. Maybe a bit too buoyant as well. So let's just rewind. And I think in this expansion scale, so I've just got the Aero combustions node selected here. Just bring it down just by one number. I'm just going to select the Arnold standard volume material node. Just bring that density up a little bit, just so things look a bit thicker. And if we just duplicate the source color and the source air, we can now bring in our other elements, which are the kind of shockwave creators, if that's what we could call them. Just bring those in one at a time. We're going to have a different source for each one. And it's kind of good to do this at this point because we just get to see everything happening all at the same time. Now the source color on these guys are just going to be picked from the scene. We're not going to be picking up the particles because we're not, this is not being driven by particles. So we'll just plug the geometry straight into each source. Just have a little tidy up. And we want to just plug that into the Aero solver. Cool, and what we really want to do for this is set a start and an end frame. So if we look at the geometry, we can see that it starts at about 12 seconds and then runs for a couple of frames. And I'll just change the inherent velocity on this just to sort of push the smoke out somewhat. And if I put in a minus number, it's going to help that shockwave kind of not rise up too much. Minus numbers allow us to sort of have a cooler effect, a much cooler effect on the Aero. I mean, in many cases we can use it for like dry ice and that kind of thing. Just getting those frame numbers right. Just going to double check that I've got those right around. No, this one should start at 12 and we'll just take that to 14. And just double check that the temperature is the same as the other one. And again, with the inherent velocity, we want that set at 2. Now we can pick some colours from our scene, which is a nice feature. And we'll do the same with the first shockwave. Just pick something around here. Cool. So I think it's about time for another play blast. So we're going to start caching now. We can lay down a file node and we're going to be caching as BOB, a Bifrost object. We can do VDB as well. In the file properties, we can see there's a little star there, which means it's going to write everything from the Aero simulation. We don't want that. So if we type in dump, we can get this dump object node. And that's going to allow us to create a text file, which is going to show us all of the different attributes which are feeding through this entire simulation to this point. So it's really important that when we're caching out, we don't cache out too much information that we don't need. So if we put that sample size to 20, we're going to get like, a fair amount of information turn up in that text file. And then if we we haven't got everything that we need there. So I'm just going to play the simulation a little bit, and that's going to enable that file to start writing. So we can see there's stuff like voxel acceleration, voxel color. We need that. That stands out straight away. That's our color coming from the particles. So if we go to the file cache node, get rid of that asterisk, and we can paste in voxel color. So that's one property that we're going to write. And then we're looking for voxel fog density. Here we go. Let's just Control C, Control V. Do a little space after that. There we go. And then I think the only one we need after this is voxel velocity. You can see that we could write all of these out, and you would write out voxel temperature if you was doing an explosion with fire, so keep that in mind. Voxel velocity, there we go. It's probably the largest one of them already, and we're going to be using that for motion blur. So let's set our frame in here, in the frame range. We're going to 1 to 100. Make sure your timeline isn't set to loop. You want that timeline set to just play once. Otherwise, when you're writing, it's going to go back to the beginning again and carry on writing again. So let's just find a spot for our cache to go. And I've written out a test earlier, but what we'll just do here is get rid of the file name and just put in 4 hashes. And that's just going to tell this that it's a number sequence. So we've got dust.hash#.bob, and so we can now plug in our simulation to file cache, and I'm just going to hit 4 so that when we're caching, we're not going to be putting extra strain on the graphics card. And if we hit play, we will start to cache. We're set on write mode, and if we go to the output folder, we should see some files starting to update. As I said, I wrote some of these out earlier as a test, but they are updating in there. As we can see, the file size is changing as we go. Right, so as if by magic, everything is cached out. And to make these cuts that you see me making to these connections here, we just hold down Shift and Alt on the keyboard, and then left click and kind of drag over, as if you would with a marquee, to make the cuts to the connections. So we can just kind of unlink all of this for a second. We need to make sure to change that mode back to read, because we don't want to be overwriting our cache again. And I'm just going to copy and paste the shading elements that we used on the Aero earlier, and all we need to do is just plug in that file cache to the assigned material and that to the output. And we no longer need that simulation. We've got everything cached, and we should be able to, let's just dock this, see our simulation in the viewport. So let's just grab a frame, let's just have a little look at what we're doing, and as you can see, we can now scrub through. It's not like the slowest, but it's all, there's a lot going on there, so that's pretty cool. If we hit 7, we can see it a bit better. There we go. Yeah, so that's all looking good. So now that's just enabled us to have like a much easier visual feedback for the next steps that we want to create. You can see it's a lot faster to play back in the timeline. It's quite efficient. The file sizes, some of the biggest file sizes got up to about 200 meg per frame, but that's that's really small for a file size, very small indeed. And so this is just going to enable us to just sort of take it on to the next steps and use this just as like a nice visual template for creating the next step, which is going to be creating some sort of debris. So over in the particle section, let's just start typing instance, because we're going to use a create instances node to kind of scatter these points. So we're going to grab the points out of the simulate particles and put that into the points section of the create instances node. Now I've created these rocks earlier just from parts of this particular scene, and we're just going to start plugging those in, and these are going to be the instances that are going to show up over the particle trails that we created earlier. Over that particle system that created the trails are where the rocks are going to instance themselves. So I'm just going to hit the tab key, start typing output, bring this output in, and just connect the instances to the output node. And I just want to make sure that we haven't got anything else plugged in, because when I start to press play, I don't want to see anything else. Let's just dock this for a second, just double make sure down here everything's undone. Yep, file cache is all undone. And then let's just unpause the graph. So to pause or unpause the graph, we can just press Control and period or full stop on the keyboard, and we can also pause or unpause the graph in the edit menu of the graph editor itself. And we should be good to go. Just check everything. Let's just get the collisions. No, let's just leave that. And then if we just rewind and play, we should see some debris. Right, I can see it. They're very tiny at the moment. We can scale these up by scaling up the original bits of geometry in the outliner. And we can scale these up, and they're going to scale up the debris. Let's just put those original rocks on a display layer. And if I rewind and play, we should be able to see debris. There we go. Now they've got no like real rotation on them at the moment, so it'd be good if we could do something to randomize the rotation as they're coming out. And so let's just switch on live forever on the actual particles, because they're popping off at the moment, as our particles did. But we'll just switch on live forever on the particle sources so that these debris stay on screen all of the time. And then now it's probably time to add some rotation to those points. So if we just start typing in randomize, we can see that we've got a randomized point rotation node, and so we'll just take the instances into the point section and the out points into the output. Now if we just go into the unshaded mode for a second, we'll be able to see this a lot easier, and we can see that they are rotating. They are kind of like, they have randomized rotation. But we could add something here that's going to kind of help animate that over time. And we could stick a fractal noise field into the weights. So if I just start typing fractal here, and we can look for a fractal noise field. So I'm just going to increase the magnitude of this fractal noise field. That's obviously going to make the effect have more weight to it. There we go. And then every time they kind of pass by some of these contrasty colors that happen inside the fractal noise field, we're going to get movement, which is yeah, that's all looking interesting. So really there's no actual real collision data going on there, but it kind of looks real based on our randomized point rotation. So that's all good. I think I'm kind of happy with that. If we add that to our smoke sim, we can look at rendering. So I've just put together the debris and the smoke sim into a quick play blast just to see what we've got going on. I'm quite happy with that for this tutorial, and I think we can move on to just having a quick look at some look dev, and then go on to rendering and get to our final product. So I'm speeding up this whole next section here because it's just a lot of me kind of playing around, getting the render set up. And to be honest, like setting up the render for this kind of thing is amazing really. It's just exactly the same as setting up renders for anything else you would do in Maya. We've got a cache scene, we've got, you know, everything's there, everything renders out of Bifrost as it would out of Maya. All I'm doing here is I've just got rid of that area light, and I'm just using the dome light now just to light the scene. Obviously using Arnold in a viewport, which is just amazing for the feedback. And you know, because we've got that cache on our Aero, we can see what it's kind of going to look like. And this all renders fairly fast, believe it or not. So yeah, I'm just going to set up a couple of crypto mats, which I may or may not use. And that's about it really. I think I just had a bit of depth of field. And then we take this into, I took this into After Effects just because it was quicker, to just do some quick compositing, get to a final result. So because Bifrost allows us to create multiple versions of an effect, we can also revisit these effects, but we don't have to do the work again. So here I'm just going to show you on like a simple area of what we've just created. I'm going to select these 3 nodes and I'm going to create a compound. So that's then kind of grouped all of those nodes together, which exist inside that compound. And if I just double click and jump down inside it, don't know why these nodes are all the way down here. But we can see that, you know, that compound's there. So I'm just going to get rid of some of the ports below it. I'll rename this top one points, so it makes more sense. Obviously the input is what you will see on the input of the actual node, upper level. So I'm just going to delete all of these, and then we're just going to plug in the instance geometries to here. And I'll just go onto that node type, right click it and change that to fan in. That just means that it will accept an array of objects. So we'll just plug all those objects in again. So we can do this on a particle system, we could do this on the Aero system, but it's just quicker at the moment for me to show you it on something like this. So I've called this instancer with random rotation because obviously that's how we set it up. And what we need to do now is just add some of those controls back onto the input. I'll start with mask weights, and anything you can kind of right click on these new compounds that you create and move them up and down or group them, and then you can kind of like place them where you want. Now with bigger setups this does take a bit of time, but it's also kind of like relaxing. But it does show you that this is a super powerful system. Bifrost is incredible for this kind of thing, because once we've created this tool set, you can share that with your team or a friend. You can email it, it's copy and paste it into different drafts, and you're literally just creating a tool. So really we've got this randomized point rotation and the field noise, but it's all just going to be on one node. So if I right click now and go add to group, we can create a new group, and this is going to be a group for the rotation values. And then I'll just right click on those attributes and add them to that rotation group. So we can see them show up in the parameters to the right there. So I'll do the same thing with the fractal noise field, just add in certain elements that I want. So frequencies, number of frequencies, etc. And again, when we get to back up a level, we can create a new group for the fractal noise. And then again, we'll just start right clicking and adding them to the group like so. And we can see that they've shown up over there in the parameters section, and now we've just got one nice tidy node. The one thing left to do is to publish this node. So if we right click on it, we can go to publish. We can see that you can change the name there. So I'll just put MG for Maya Guide to the beginning of it, making sure to add an underscore, and then we'll hit publish. So I can then just delete that node and then just start typing in MG, and we can see that node turns up, and we'll just test it out. Add in the points from the particles, and then adding in all of our geometry again. And then if we just have a little look at our simulation to see if it's working, start playing, there we go, they're all turning up. I'll just select them so you can see it better. And then just on the node itself, we've got all of those attributes that we pulled through, and we can, they work still. You can see everything rotating. And we've created our own little tool, which again, I never have to create that setup again. That's now part of my tool set. So that's kind of the amazing scalability that we can see with Bifrost. So the next time that you start working on a client's project or within your team, you can hit the ground running with these pre-built effects. They're incredibly powerful, and as I said, incredibly scalable. Thanks for watching this, and I'll see you on the next one.